A gigantic void could solve one of the greatest mysteries of the universe. The James Webb Telescope has found new evidence that the Hubble strain is real. This means that we are once again making scientific advancements. The latest discoveries suggest that our universe may be in constant evolution, something scientists had not predicted. This implies that we know almost nothing about the true nature of the universe. Are we going back to square one in our research? Huge voids, several million light-years in diameter, point researchers to an unsolvable mystery. These gigantic voids should not exist, according to Einstein's relativity equations and our old cosmology. These old calculations could only describe part of the universe. It's clear that since the launch of the James Webb Space Telescope, we have seen so many incredible indications that there is more to the universe than we can currently grasp. The structures of voids are among the most amazing and fascinating in the universe. Their size alone pushes the limits of our imagination. The largest void currently known measures 100 million light-years in diameter. If a particle of light were to begin a journey at one end of the void, it would take 100 million years to emerge at the other end. Now imagine, inside these voids there is practically nothing. In a space where you would normally find hundreds or thousands of galaxies, there is simply nothing. Our universe is, in fact, traversed by enormous fibers, structures that act like cosmic force lines, along which matter migrates. Systems move coherently with these structures, and even galaxy clusters abound where the fibers form large convergences, attracting matter. It is therefore reasonable to assume that there are fewer fiber structures in the voids and, consequently, less matter accumulates there. But this should not be the case. The Hubble strain solves the greatest mystery of the universe. If it is proven that our universe is made of uniform structures, the mystery remains as to whether these structures are homogeneous or inhomogeneous. Homogeneous means identical. Inhomogeneous would imply more chaos. Now, you could say this doesn't matter, but it's not so simple because from this seemingly modest question depends a great decision about how the universe is actually built and how it works. We, humans, always want to know exactly what the universe is in order to learn more about ourselves and the true nature of the space in which we live. Our previous ideas about the Big Bang and expansion almost necessarily required a homogeneous or isotropic universe, that is, uniform. This idea has been shaken since the launch of the James Webb Space Telescope because something that shouldn't be there has already been observed since the 1990s. Since we are now able to observe larger and larger aspects of the universe, we have tried to measure them. You can probably imagine that it's not so simple because measuring spaces of several millions, or even just a few thousand light-years is no small task. The dimensions are enormous, and no one can simply take a ruler or a terrestrial GPS to measure them. You must imagine that what exists in the universe is in constant motion. Stars move, planets orbit stars, and even entire star systems travel through the galaxy and the universe at incredible speeds. Universes migrate and spin, and we still don't know the extent to which even dark matter in the vast spaces between them moves and changes. Taking measurements here is akin to a challenge that our science has not yet fully mastered. Using light, we know that light behaves in a relatively constant way. The speed of light is the only quantity that is constant, that is, non-relative, that Albert Einstein was able to find in the universe. Scientists have therefore used quantities of light to measure distances. One of these quantities is the Cepheid variable, a special class of stars whose absolute luminosities behave similarly and linearly to those of type 1a supernovae. These tools are called standard candles by scientists, and they were actually considered largely reliable until the Hubble strain appeared. Hubble had a miscalculation, and we now know why. Edwin Hubble, the astronomer after whom the famous telescope is named, was one of the first researchers to describe the expansion and plausible features of the universe. Hubble conducted his research at a time when astronomers were beginning to see beyond the Milky Way. It may seem incredible today, but at the time, researchers thought the Milky Way existed in a vast void. It's only been about 100 years since we, humans, learned that other systems exist in the universe and that space is full of matter and many other cosmic phenomena. Based on Hubble's early calculations about the true aspects of the universe, other measurements were made, which showed a consistent picture for a long time. However, a measurement discrepancy then occurred at great distances, which came to be known as the Hubble strain. The Hubble constant was suddenly no longer reliable, and since then, scientists have wondered how this discrepancy in measurement could have happened. Imagine that to measure a distance, scientists use one time a measuring stick and another time a digital measuring device. The results differ from one another, yet the researchers can find no flaw in either the measuring stick or the digital measuring device. What then is the reason? That is precisely what the Hubble strain represents on a cosmic scale. Hubble's ideas about the true nature of the universe implied a homogeneous and largely linear universe, but today we find more and more evidence that this is not the case. To understand the homogeneity or isotropy of the universe, it's enough to imagine an ocean. Technically, an ocean is a space or volume filled with water. Of course, many creatures evolve in this ocean, and there are structures like trenches, reefs, underwater volcanoes, and many other things. On the surface, you would see waves, and even though this may seem chaotic to you, scientifically, it is isotropic. Recent discoveries from the James Webb Space Telescope and the vast voids would mean that there is suddenly a hole in the ocean where there is nothing. But this is not possible, not here on Earth. However, the voids in the universe are just that, voids. If there can be holes or inconsistencies like voids, then there may be other strange phenomena in the universe that our science has not yet uncovered. The magic of these new discoveries is that we are now realizing that the universe is built quite differently from what we once thought. What is the true meaning of the voids in the universe? If voids are proof that our entire cosmology is wrong, then what is the truth? Did the Big Bang really happen? And is the universe still expanding from a single point of origin? But then the universe would have to be isotropic, that is, homogeneous. However, since the launch of the James Webb Space Telescope, we now know that the universe is very likely not isotropic. From the very start of its mission, the telescope has shown us images of an incredible number of galaxies that existed so close to the Big Bang that they shouldn't have existed. Their mere presence contradicts the rules of cosmology and the calculations of the universe's age. In addition to the telescope, an enormous structure was observed behind the M of Pandora, containing several hundred, possibly even thousands, of systems that should not exist. Not only is this structure far too large to exist in a homogeneous universe, but it also contradicts the laws of the Great Explosion, Big Bang. The voids also contradict these rules. A few months ago, researchers found evidence of enormous radioastronomical structures, among the largest ever discovered in the universe. According to the old rules of cosmology, these should be unimaginable. In 2015, scientists discovered a group of over 70 quasars gathered over a distance of 4 billion light-years. As a group, they also represent an object type that remains a complete mystery. Quasars are the cores of extremely bright cosmic systems that could date back to the early days of the universe. At least, that's what researchers thought until now. However, the discovery of cosmic systems too old to exist according to the laws of our astrophysics and cosmology, as well as the observation of structures too large to form in an isotropic universe, indicate that we have fundamentally misunderstood the universe up until now. Some scientists admit that, despite our massive progress in research, we are probably only at the very beginning of understanding the true nature of the universe. What if we have only scratched the surface? What if the universe is infinite? And what if, beyond the visible, matter or even light are not the measure of all things? It seems incredible, but the voids might be something like counterworlds in our universe. They could also be dimensional portals where universes overlap. American researchers have found data suggesting that voids could be remnants of gigantic crashes between universes and entire cosmic aspects. Some scientists even believe that voids might be inhabited by extraterrestrials who obscure normally visible matter in order to extract energy from the universe. This hypothesis is based on a well-known theory. The idea of supercivilizations comes from Russian researcher Nikolai Kardashev, who, in the 1960s, scientifically proved that there must be highly developed species within the universe. These supercivilizations would be capable of obscuring entire worlds with their power plants. They could theoretically manipulate the laws of the cosmos and even influence our thoughts without us realizing it. As a result, voids could be spaces where matter has been removed or altered in a way that is alien to us. These ideas may seem fantastical, but they are based on logical reasoning. However, they have never been confirmed through observation, unlike other theories that eventually became our accepted view of the world. The fact is, the James Webb Telescope and recent observations push the limits of what we once thought was true. Our science must now be ready for new shocks. Subscribe to the channel now and join us in exploring many more exciting videos.